Okay, so today it's our Friday lesson. So happy Friday. We're going to look at total surface area, lateral surface area, and volume of cones. Yesterday we did pyramids. Today we're doing cones. They're really similar. The only difference now is that every single time the base will be a circle because it's a cone. So similar concepts, but now the base is a circle. So let's just jump into it, look at the formulas, talk about what some things mean, and we'll go from there. But for lateral area, the formula that you'll see on your formula chart is pi r squared. Sorry, not pi r squared. What am I talking about? I don't know what I'm talking about. Not pi r squared. Pi rl. Pi rl. Now we know what pi is. Pi is just pi. R is your radius. And L was that new one we learned yesterday. L is slant height. Remember, this is along the outside of the cone. This is the outside. How far from the tip along the outside down to the bottom? So I'm just going to make a note of that. This is the outside. Okay, so that's lateral surface area. Total surface area, well, we have to have the lateral in there with it. And then we've got to add a base. The base is a circle, so we're going to add pi r squared. And then volume is actually the same formula as a pyramid. 1/3 BH. Where B is capital B is the area of our base. And then there's not a blank down here, but H is the height. Okay, now on this one, just like we said on cylinders a couple of days ago, on this one, the big B, it's a circle. So big B is just pi r squared. So another way we could write this would be 1/3 pi r squared times height. That's another way we could write that, because big B is just pi r squared. Okay, so now for our examples. Main things we're going to need are R, L, and H. R, L, and H. Those are the three things we want to identify. R, L, and H. Let's see. R is 5 feet. Ooh, they don't give me L, but they do give me the height is 12 feet. So I'm going to just kind of sketch this in here on our initial picture. That's our height. That way we have a visual now. Okay, we need to realize this is a right triangle, so we can do the Pythagorean Theorem. 5 squared plus 12 squared equals L squared. 5 squared is 25. 12 squared is 144 equals L squared. Add those together, you get 169 equals L squared. When we square root, this is a nice one. It comes out to 13 on the dot. So our L is 13 feet. So we have everything we need to solve our problem now. Now, one thing I want you to notice, this last part, give your answer in terms of pi. So today we are not touching pi. Unless told otherwise. Okay, lateral area. Pi times R times L. Well, pi times, that's going to be pi times 5 times 13. 5 times 13 is 65. And then I'm going to have my pi, feet squared. So this will be 65 pi feet squared. Then we have total surface area. Our formula says pi r L plus pi r squared. So pi times 5 times 13 plus pi times 5 squared. Now, since I cannot put pi in the calculator, I'm just going to do the 5 times 13 plus 5 squared. That'll get me 90 pi feet squared. And then we have the volume. So volume, the formula that you'll be given is 1/3 BH. But realize our big B is a circle. So this can be turned into 1/3 pi r squared times h. So let's plug things in. It's going to be 1/3 pi. R is 5. So 1/3 pi times 5 squared. H is 12. So we're going to put everything but the pi in there. We're going to do 1/3 times 5 squared times 12. No pi. This will be 100 pi feet cubed because we're doing volume. So 100 pi feet cubed. Okay, there's our first example. Next one, they give us a cone with a radius, and I'm going to write these things down as I do them. A radius of 3, a slant height of 5 meters. But notice they don't give us a height. We don't know height. So think to our little triangle over that we had. Come on, keep going. Think to our right triangle that we had. Height, R, and L. I don't know height. I know radius is 3 and L is 5. So I'm going to have to use the Pythagorean Theorem to get H. So 3 squared plus H squared equals 5 squared. 3 squared is 9. 5 squared is 25. Subtract 9. We're going to get H squared equals 16. Take the square root, you get H is 4. So our height is 4 meters. So here's everything we need to use to find the areas and the volume. So let's do it. So lateral area. We need pi RL. It's going to be pi. R is 3 times L is 5. We're not touching pi, so we just do 3 times 5, which gives us 15 pi meters squared. Okay, now for the next one, total surface area. We're going to need pi RL, but we're also going to need pi R squared. So it's going to be pi times 3 times 5 plus pi. Our radius is 3 squared. So again, you type everything in but the pi. So 3 times 5, then you do the plus, and then 3 squared. That'll get you 24 pi meters squared. Then we have volume. So volume, our formula for that's given is 1/3 BH. But remember, the capital B is just pi r squared. And then we have our h. So this is going to be 1/3 pi. R is 3. So pi times 3 squared. H is 4. So if we use our calculator, we type everything in but the pi. No pi for you. We're going to get 12 pi meters squared. No. I'm doing volume. What's wrong with that? It's not meters squared for volume. It's meters cubed. It's too early for math. If you look at my screen, I'm recording this at 4 o'clock in the morning. It's too early for math. Okay, now I just want to refresh your memory on how to put this in Google Classroom or Google Forms. So for Google, if you're doing this on Google, I want to just kind of put here Google. This volume, for instance, you'd say 12 in just the easiest sense possible. 12 pi meters, and then you would look for the caret and then a third power. That's how you can put that into Google Forms. So I'll remind y'all again on the guided practice, but as far as doing this online, that's how you do it online. And not have to worry about where do I get the pi from? Where do I get the small 3 from? That's how you type it. Okay. So it says find the volume of the composite figure. We're going to give our answer in terms of pi. So what two shapes do I have here? What are my two shapes? I have a cylinder down here. And I have a cone up here. So on both of these, well, the cylinder, they give you the height. The height is 45. How much does that leave me with then for the height of my cone? Well, I can do 90 minus 45. 90 minus 45 is 45. So this leaves me with 45 more centimeters for the height of my cone. And the radius is 28 centimeters. Okay, so let's find, we want to find volume. So let's do the volume of the cone first, since that's what we're working on today. Our formula says 1/3 BH. So we know that capital B stands for pi r squared. Okay, well, I think we have everything. Let's see. 1/3 pi. Do we know the radius? Yep, 28 is our radius. So 1/3 pi, 28 squared. 45 is our height, so times 45. And then we'll type everything in but the pi. And these are some big numbers. So you'll get a big answer. It's going to be 11,760 pi. Okay, now we need the volume of the cylinder. So the cylinder on the formula chart, they give you BH. But again, we're dealing with the cylinder, so we know B is just pi r squared times H. So pi r for the cylinder is the same. So r is going to be 28 again. Pi times 28 squared. The height of the cylinder is 45 as well. So if we type 28 squared times 45 in the calculator, we'll get 35,280 pi. And then to get the total volume, we add them together. So that's going to be 47,040 pi centimeters cubed. Okay, that's it for the notes. So cones were the main focus of today. Stay tuned for the guided practice.